We want to make a model of the solar system in which both the sizes and distances of objects are scaled accurately. This is harder than you might think. The average distance from the Earth to the Sun, 93 million miles, is called 1 astronomical unit. In our scale model, 12 yards will represent 1 astronomical unit. On this scale, the Sun is a ball slightly more than 4 inches in diameter. The largest planets are less than an inch in diameter, and the smaller planets are less than a millimeter. We have to keep the planets so small, or else the size of our solar system would be unmanageable, as you will see. We can place all the planets at their appropriate scale distances from the Sun. Mercury, the closest planet to the Sun, is 4.5 yards away in our scale model. We go another 4 yards to reach the orbit of Venus. As we planned, the Earth and its moon are 12 yards from the Sun, representing 1 astronomical unit. The moon is about an inch away from the Earth. Mars is 18 yards from the Sun. Between the orbits of Mars and Jupiter is the asteroid belt. We're using flour to represent the asteroids, but many are so small that they would be invisible to the naked eye at this scale. We need to go a total of 62 yards from the Sun to reach the orbit of Jupiter, the largest planet in our solar system, and the first of the gas giants that are found beyond the asteroid belt. Next comes Saturn with its amazing rings, which is 114 yards from the Sun in our scale model. Looking back from Saturn, the Sun would appear about 10 times smaller and 100 times dimmer than it looks from here on Earth. Beyond Saturn is Uranus, another gas giant about 4 times the diameter of the Earth. Uranus is more than 1.7 billion miles from the Sun, which is 230 yards in our scale model. Moving out from Uranus, we eventually reach Neptune, which is slightly smaller than Uranus. Neptune is about 360 yards from our Sun in our scale model. Finally, we can move out to the orbit of Pluto, which averages about 3.6 billion miles from the Sun, or 476 yards in our model. It is about 40 times farther from the Sun than the Earth is, so we can say that Pluto is 40 astronomical units away from the Sun. Looking back from Pluto to the center of the solar system, the Sun would be 40 times smaller and 1,600 times dimmer than it appears from Earth. Pluto is part of the Kuiper Belt, a region that contains thousands of cold, rocky objects. Far beyond the Kuiper Belt is the Oort cloud, which consists of icy bodies that can become future comets if gravity pulls them into the inner solar system. The Oort cloud is extremely large, possibly extending halfway to the nearest star system, the Alpha Centauri group. This ball represents Alpha Centauri, one of a group of 3 stars that are about 4.3 light years away. A light year is the distance that light travels in 1 year, about 5.9 trillion miles. Where does Alpha Centauri belong in our scale model? To keep the scale accurate, we would have to place this ball somewhere in the vicinity of Estes Park, Colorado, about 1,900 miles away. You can see that if we wanted to make a practical model that includes many of the stars that are nearest to our sun, we would need to shrink to a much smaller scale. The distances between the stars are immense.